Okay, so today we are going to be looking at what I referred to about in the last couple of sections, something brand new to you, something called a logarithm. Okay, now there's two ways to look at these. Okay, so let's say we started out with this, a to the x equals b, where the variable is up in the exponent. We can switch it to logarithm form, where the a will become this little base number down here, and then log base a of b is equal to whatever your exponent is, or x. So this is a way to get to the exponent completely by itself. Okay, so solving for the exponent. So this would be, again, how you would say that. It's written in quotes down there. So we're just going to practice switching to the other form. Okay, so again, remember that the logarithm, which is a button on your calculator that we're going to use, is getting the exponent alone. So whatever the exponent is on these problems right here is going to be what's all by itself on the right-hand side. Another way that I remember the order that they go in is this. See this 5 right here? It's raised to something. This number right here is also going to look like it is raised to something when you write it in log form. So there's always going to be a number up above it. So whatever number has a number up above, so in this case the 5, it will also look like there's a number up above it when we write it in log form. Okay, so we're not solving these, we're just getting used to switching in between the two forms. So we've got log, what's the little number down here? 16. 2 equals 1/4. Again, we're trying to get the exponent alone on the right-hand side. So this one is going to be log base 3 of 27 exponent of 3 on the other side. Log 169, 13 equals 1/2 as the exponent. Log base 4 of 16 is 2. And log base 7 of 49 is 2. Okay, so it isolates that exponent. We're just going to practice switching the other direction before we get into actually solving some problems. Okay, so if they start in log form and they want you to switch it back, I'm going to ask you to do this on the test. So these are the most basic log problems possible because we're just rewriting it. Okay, remember these are the exponents right here. So we've got 6 to the 2 equals 36, which is true. Okay, so each time you write these, they should be true equations. So here we've got 81 to the 1/2 is 9. Hopefully you're able to fly through this, and hopefully you're further than me along in this process here. Biggest thing to remember is this is your exponent right here. That 8 to the 1/3 is 2. 5 to the 3rd, 125. Questions? Okay, so now we're going to actually solve some problems doing this, but the homework is going to start out with you just switching back and forth. Okay? Question? Yes. Oh, it's just random. He loves logarithms. Mm-hmm. All right, so here's how we're going to do this. So let's say they give you this as your original problem. Okay? These are each of the steps that we're going to go through. Right here, what did we do from here to here? That's the only thing that's different. Okay, so we're going to set equal to x. That's your first step. What did we do here? Okay, so we switch to exponent form. Having these steps is going to help you when you get to the homework. Okay, then what did we do? Okay, so turn to base numbers. Told you these base numbers aren't going away. Okay. What did we do here? We dropped the base numbers, or we could say set exponents equal. And then solve for x. So this is what we're gonna practice on the next page. Are these steps right here? You ready? All right. First step, set it equal to x. So we put an x on the end. Then we're gonna rewrite it in exponent form. What would that look like? 5 to the x equals 125. Now we change it to base numbers. This one already is a base number. This one is 5 to the third. We simplify our exponents. There's nothing to simplify. We set our exponents equal, and then we solve for x. Well, it's already solved, so we're done. You need to get really comfortable with switching in between log form and exponent form. That's really where the success is going to lie for this chapter. Okay, so this one we set equal to x. We change to exponent form. 2 to the x is 16. Change them to their base numbers. And then set your exponents equal. This one's a little bit different. Set it equal to x. Change it to exponent form. Now we have to write them as base numbers. We've seen examples like this in the last couple of days, but how would you write this as a base number? 2 to the negative 1. But 2 is on the bottom, so to move it you have a negative exponent. And then we've got 2 squared over here. Simplify the exponent. Set the exponents equal. And then solve for x. We need to divide by negative 1 here. Okay. This one. Set it equal to x. Rewrite it in exponent form. We need to change both of these to base numbers. What's 8? Yep. What's this guy? 2 to the negative 2. Okay, we'll simplify our exponents. Set those exponents equal. And then solve for x. Questions? Okay, same thing here. Set it equal to x. rewrite it in exponent form, so that would be 3 to the x equals 3 to the 7. It's already in base numbers, right? What's the answer? X equals 7. And the last one. You are going to see this quite often. They're just going to have log of a number. They're assuming that you know that there is a little 10 there. Okay, so you put a 10 there, and then we do the same process. Equals x. Write it in exponent form. Turn it to base numbers. This is 10 to the... Set your exponents equal. Questions?